Hello guys, this is Sir EJ and welcome again for another math tutorial. In today's topic, we will be discussing the 6 trigonometric ratios. These are the following objectives we need to attain for today's topic. Letter A. Illustrate the 6 trigonometric ratios, the sine, cosine, tangent, secant, cosecant, and cotangent. Letter B. Apply the trigonometric ratios to solve the right triangles. And letter C. Appreciate trigonometric ratios in solving real-life problems. We can solve for the missing parts of a right triangle given the measure of the two parts of the right triangle. So the first given, if the length of the hypotenuse and the length of one leg is already given. The second one is if the length of the hypotenuse and the measure of one acute angle is already given. And the third one, if the length of one leg and the measure of one acute angle is already given. And for the last one, if the length of the two legs is already given. So these are the four conditions that we need to consider for us to solve for the missing parts of a right triangle using the trigonometric ratios. So these are the 6 trigonometric ratios. So we have sine theta is equal to opposite side all over the hypotenuse. Then we have cosine theta equals adjacent side all over the hypotenuse. And then we have tangent theta is equal to opposite side divided by the adjacent side. And then cosecant theta is equal to the value of the hypotenuse divided by the opposite side. And then secant theta is equal to hypotenuse divided by the adjacent side. And we have cotangent theta is equal to the adjacent side divided by the opposite side. Now to easily memorize this 6 trigonometric ratio, let's have this acronym. So we have SO, KA, TOA, CHO, SHA, KAW. So remember this acronym. So we have SO, sine is equal to opposite over hypotenuse. Cosine is equal to adjacent over hypotenuse. Tangent is equal to opposite over adjacent. Cosecant is equal to hypotenuse over opposite. Secant is equal to hypotenuse over adjacent. Cotangent is equal to adjacent over opposite. So the acronym SOCAT, TOA, CHO, SHA, KAW. Let's identify first all the 6 ratios for all the acute angles of triangle BCA. So, the measure of segment AC is 4 inches, measure of segment BC is 3 inches, and the measure of the hypotenuse segment AB is 5 inches. Let's start by finding all the 6 ratios for angle A, if the given angle is angle A. So let's compute first for the value of sine theta. So for sine theta, our formula is opposite over hypotenuse. So let's look at our given angle, which is angle A. So the opposite side of angle A is equal to 3 inches. And the hypotenuse of the triangle is 5 inches. So this will be 3 over 5. So sine A will be equal to 3 over 5. Next, let's compute for the value of cosine theta. So for cosine theta, we have the formula adjacent over hypotenuse. We will be identifying the adjacent side of angle A. So the side in between the given angle and the right angle. And that is equal to 4 inches. And for the value of the hypotenuse is equal to 5. So this will be 4 over 5. And then next one is the tan theta or tangent theta, which has a formula of opposite over adjacent. So the given angle is angle A. The opposite side, the measure of the opposite side is equal to 3 inches, and the measure of the adjacent side is equal to 4 inches. So this will be equal to 3 over 4. And then for the next one, we have the cosecant theta is equal to the value of hypotenuse over the opposite side. The hypotenuse will be the longest side of the right triangle, which is equal to 5 inches. The opposite side of angle A is equal to 3 inches. So we have 5 over 3. And the next one, we have the value of the secant theta. So to compute for the value of secant theta, we will be using the formula hypotenuse all over the adjacent. So the value of the hypotenuse again is equal to 5, and the value of the adjacent side is equal to 4 inches. So we have 5 over 4. And then next for the cotangent theta or cotangent A, we will be using the formula adjacent over opposite. So the adjacent side again is equal to 4 inches, and the opposite side of angle A is equal to 3 inches. So this will be equal to 4 over 3. Now notice that the value of sine A and the value of cosecant A is reciprocal with each other. So this one is 3 over 5 and this one is 5 over 3. Once you have multiplied these two numbers, this will be equal to 1. So they are reciprocal with each other. Same goes with the value of cosine A, which is 4 over 5, and the value of secant A. And same goes with tangent A. It is reciprocal with the value of cotangent A. So this is 3 over 4 and this one will be 4 over 3. So that is the relationship formed between those trigonometric functions. They are reciprocal with each other. Next, this time, let's find all the 6 ratios for angle B. So if angle B is the given angle, let's start with sine theta, opposite over hypotenuse. So the opposite side of angle B is side AC, and the measure of side AC is 4 inches. And the hypotenuse, the longest side of a right triangle, is equal to 5. So we have 4 over 5. And then we have cosine theta is equal to adjacent over hypotenuse. So the value of the adjacent side, the side in between the given angle and the right angle, is equal to 3 inches. And the hypotenuse is equal to 5 inches. So we have 3 over 5. Next one for tan theta equals to opposite over adjacent. Let's look at the given angle, angle B. So the opposite side is 4 inches and the adjacent side is equal to 3 inches. So tan B will be equal to 4 over 3. Next, let's compute for cosecant theta, which is equal to the hypotenuse over opposite. So since cosecant theta is reciprocal with sine theta, let's just alternate the value of 4 over 5. So 4 over 5 will be 5 over 4. So that will be the value of cosecant A, 5 over 4. Next, since secant theta is reciprocal with cosine, so the value of cosine is 3 over 5. So this will be 5 over 3. The value of secant P is equal to 5 over 3. And for the cotangent theta, this is reciprocal with tangent theta. So the value of tangent theta or tangent B is 4 over 3. So the value of cotangent theta will be 3 over 4. So that's how we identify all 6 ratios for all the acute angles of triangle BCA. So let's now solve for the missing parts of this right triangle using the trigonometric ratios. So the given here is triangle BCA is right angled at C. So meaning to say angle C is equal to 90 degrees. If C or the hypotenuse is equal to 27 and angle A is equal to 58 degrees, find angle B, side B, and side A. So the first thing we need to do is to compute for the missing angle. So the missing angle is angle B. So to solve for the measure of angle B, we will use the formula angle A plus angle B plus angle C is equal to 180 degrees. The sum of the 3 interior angles of a triangle is equal to 180 degrees. we will be substituting the corresponding value. The value of angle A is equal to 58 degrees, and the value of angle B is unknown, and the value of angle C is equal to 90 degrees since this is a right angle. Substituting the corresponding values, we have 58 degrees plus angle B plus 90 degrees is equal to 180 degrees. Then let's add this first. 58 degrees plus 90 degrees will be equal to 148 degrees. Bring down angle B equals bring down 180 degrees. Then bring down angle B, bring down 180 degrees, transpose 148 degrees positive, it will become negative. So we have 180 degrees minus 148 degrees will be equal to 32 degrees. So the measure of angle B is equal to 32 degrees. So the next one is we want to compute for the measure of side A. So this side, the measure of segment BC. And we will be analyzing what formula to be used. So since angle A is the given angle, so side BC is the opposite side of angle A. And then the only given here is the hypotenuse, which is C is equal to 27. So we cannot use segment CA because this has no given. So to compute for the measure of segment BC, we need at least two given. The first given is the measure of the given angle, and the second given must be a side of a triangle. So we will be using the hypotenuse. So the formula that we will be using is sine theta is equal to opposite over the hypotenuse. And all we need to do is to substitute the corresponding value. So we have sine 58 degrees, so theta is the value of the given angle. So this will be sine 58 degrees equals the value of the opposite side, which is unknown, that is A, all over the hypotenuse, which is already given, and that is equal to 27. The next step we need to do is to cross multiply this. So we have sine 58 degrees times 27 will be 27 sine 58 degrees. Then A times 1 will be equal to A. Next step, just press sine 58 degrees on your calculator first, and that is equal to 0.8480. Then after that, you will multiply it by 27. So 27 times 0.8480 will be equal to 22.90. So the measure of segment BC or side A is equal to 22.90. After we have compute for side A, let's now find the measure of side B. And let's look again for the given angle. So we can use the formula of the secant here, since the value of the hypotenuse is already given and we are looking for the adjacent side. So using the formula, we will substitute the corresponding value. So we have secant 58 degrees, the value of theta is the given angle, equals the value of the hypotenuse is equal to 27 all over the adjacent side, which is unknown. So we have secant 58, just press it on your calculator, it will be 1.887 equals 27 over V. Then let's cross multiply. 1.887 times P is equal to 1.887B equals 27 times 1 will be equal to 27. Then to get the value of B, let's divide this both sides by 1.887. Then this will be cancelled out. So B will be equal to 27 divided by 1.887 is equal to 14.31. So the measure of segment CA or side B is equal to 14.31. Let's have our second example. Triangle ACB is right angled at angle C. If angle A is equal to 63 degrees and side A is equal to 11 centimeter, find the measure of angle B, side B, and side C. So let's find first the measure of angle B. So to find the measure of angle B, we can use the formula angle A plus angle B plus angle C is equal to 180 degrees. The sum of the three angles of a triangle is equal to 180 degrees. Or we can use the formula angle A plus angle B is equal to 90 degrees. Since this one is a right angle, so angle C is equal to 90 degrees. The sum of the two remaining angles is equal to 90 degrees. So the two angles are complementary. So we can use the formula angle A plus angle B is equal to 90 degrees. Let's substitute the value of angle A, which is equal to 63 degrees, plus angle B equals 90 degrees. Transpose 63 degrees, positive 63 degrees will become negative 63 degrees, and then 90 minus 63 degrees is equal to 27 degrees. So the measure of angle B is equal to 27 degrees. So after we have compute for the measure of angle B, let's now compute for the measure of side B. So to compute for the measure of side B, let's look at the given figure and see what is the available given. We need at least two given. So the available given here is 63 degrees and A is equal to 11. So we need the opposite side, and we are computing for the value of side B, so we need the adjacent side. So we can use the tangent TOA, opposite over adjacent, or cotangent, adjacent over opposite. So let's use tangent for this problem. So we have tangent theta is equal to opposite over adjacent. So substituting the corresponding value, so we have tan 63 degrees is equal to the value of opposite side, which is equal to 11. Then the value of the adjacent side is equal to b, unknown. So we will simplify, just cross multiply. So tan 63 times b is equal to b tan 63 equals 11 times 1 is equal to 11. And then let's compute for the value of tan 63, which is equal to 1.9626 times b equals 11. Then let's divide this both sides by 1.9626 to get the value of b. This will be cancelled out. So b is equal to 11 divided by 1.9626 is equal to 5.6 centimeter. So the measure of side B is equal to 5.6 centimeter. Next, let's now compute for the measure of side C. So let's look at our given figure. So this is side C. So the given here is side A. So this is the given angle 63 degrees, and side A is the opposite side, and this one is the hypotenuse. So we can use the formula of cosecant or sine. So let's use the formula of cosecant. So the formula of cosecant is equal to hypotenuse over opposite. So substituting the corresponding value, so theta is equal to 63 degrees, the value of the given angle, equals the value of the hypotenuse is equal to unknown, all over the value of A, which is equal to 11. And then let's simplify this. Let's cross multiply. So we have cosecant 63 degrees times 11 is 11 cosecant 63 degrees. And then C times 1 is equal to C. Bring down C, then press cosecant 63 degrees first on your calculator. The answer will be 1.1223 times 11. Multiplying these two numbers, the measure of the hypotenuse will be equal to 12.35 centimeter. So let's have our last example. Find all the missing parts of right triangle BCA. So we have the following given. The measure of the hypotenuse is equal to 23. The measure of side B is equal to 17. And the measure of side A is unknown. The measure of angle A is also unknown. Same goes with angle B. Let's look first for the measure of angle A. So to find the measure of angle A, we need at least the measure of the two sides of the triangle. So in this given figure, we have two sides of the triangle which is already given. So the measure of B is equal to 17 and the measure of C is equal to 23. So if angle A is the given angle, then side B is the adjacent side, and side C is the hypotenuse. So we will look at the 6 trigonometric ratios. So which of the formula has the adjacent side and the hypotenuse? And that is cosine and secant. So cosine is equal to adjacent over hypotenuse. Secant is equal to hypotenuse over adjacent. So you can choose any of those two formula that you can use to solve for the measure of angle A. So let's use the formula of cosine. So we have cosine theta is equal to adjacent over hypotenuse. Let's substitute the value of adjacent. So adjacent is equal to 17. Then over the hypotenuse, the value of C is equal to 23. So we are looking for the value of angle A. So we have cosine A. So let's divide this number. 17 divided by 23 is 0.7391. And then we will divide this both sides by cosine to get angle A. And then cosine will be cancelled out. So A will be equal to cosine negative 1. So cosine positive 1, we will put it on our numerator. So the positive exponent will become negative exponent. So positive 1 will become negative 1 times 0.7391. So press this on your calculator. Cosine negative 1 times the quantity 0.7391, the answer will be equal to 42.34 degrees. So the measure of angle A is equal to 42.34 degrees. Next, let's now solve for the measure of angle B. So since we have already the measure of angle A, which is equal to 42.34 degrees, and we all know that the measure of angle C is equal to 90 degrees, we can solve this using angle A plus angle B plus angle C is equal to 180 degrees. The sum of the three angles of the triangle is equal to 180 degrees. So we have angle A plus angle B plus angle C is equal to 180 degrees. Substituting the corresponding value, so angle A will be equal to 42.34 degrees plus angle B, which is unknown, plus angle C, which is equal to 90 degrees, equals 180 degrees. So 90 plus 42.34 is equal to 132.34. Bring down angle B equals bring down 180 degrees. Transpose positive 132.34. Positive, it will become negative. So we have 180 degrees minus 132.34 is equal to 47.66 degrees. So the measure of angle B is equal to 47.66 degrees. And for the last one, we will look for the measure of side A. So to solve for the measure of side A, let's just use the Pythagorean theorem since we have the value of B and the value of C. So using the Pythagorean theorem, C squared is equal to A squared plus B squared. Substitute the corresponding value. C will be equal to 23 raised to the second power equals A squared unknown plus the value of B is equal to 17 raised to the second power. 23 times 23 is equal to 529 equals A squared plus 17 times 17 is equal to 289, and then bring down A squared equals, bring down 529, transpose 289 positive, it will become negative, and then subtract these two numbers. 529 minus 289 is equal to 240. So A squared is equal to 240. Multiply this both sides by square root. So squared and square root will be cancelled out. So A will be equal to square root times 240 is equal to square root of 240. And square root of 240 is equal to 15.49. So the measure of side A or segment BC is equal to 15.49.